Ladies and gentlemen, it is time for us to do some more learning. I'm not particularly worried about the vocabulary. It gets lots of words and really confusing. So let's get to what we're trying to learn today. What we're trying to learn today is how to do cross product properties. It's an easier way to solve proportions than what we were looking at yesterday, I think. And so what we're going to look at are things that are called cross products. And in math, we usually call stuff exactly what it is. So cross is going to mean that they are like form a crisscross, and product means you're going to multiply. The cross products of a proportion are equal. That's what we're going to get at. So what does that mean? That means, and what this little box is saying, is if I have one ratio of A over B and I'm comparing it to another of C over D and they're equal, when you have that proportion, this product, A times D, will be equal to this product, B times C. And so setting it up like that is a good way for me to solve for one of the unknowns. So they give an example here where they say 5 over 6 equals 10 over 12. And what we were doing is we were looking and saying, okay, 5 times 2 is going to be 10, 6 times 12 is going to be 10. And that works, but it's not the most efficient way to do it. The more efficient way to do these once we're trying to compare or solve is to check those cross products. Does 5 times 12 equal 6 times 10? And then a quick check on your calculator shows, yeah, those are equal. So that is an equal proportion. So this is the real gist of it. And again, it's called cross products because you're making this crisscross and you're multiplying, which is a product. So how does that help us solve? So I'm not going to show all the work in this manner. I feel like it's super confusing. But if we had something like this from yesterday, but the other side was also a fraction, it can start to be kind of confusing because the y is on the bottom. So then what we're going to do is we're going to do our cross products. We're going to take this product, 5 times 75 has to equal this product, which is y times 15 or 15 times y. And I'm writing it that way because it's easier. So I'm going to go ahead and take 5 times 75 on my calculator, and I'm going to get 375. And then I'm going to use what I learned earlier in chapter 3 to say the 15 is multiplied in. So I'm going to go ahead and divide that out on my calculator. And when I do, I find out that y equals 25. And again, if you want to make triple sure that you're doing this right so that you don't have to take more time on assignments, then you can come back to this and say, okay, I'm going to go ahead and plug in what I got. 5 over 25 equals 15 over 75. And then I'm going to check my cross products. Just quick on my calculator. Is 25 times 15 going to equal 75 times 5? And when I do 25 times 15, I get 375. When I do 75 times 5, I get 375. So I know, like, obviously in my years of experience that a lot of kids don't like to check their work. The only reason I keep showing that to you is if you're doing IXLs or assignment checks and you only have one shot at getting it right, it might be worth taking the time to do that. So how's this going to look if you have to like solve an actual problem? So let's take a look. To feed your plants, you need to mix 3 tablespoons of plant food with 16 ounces of water. So what I do is as I read, I kind of put that together. So it takes 3 ounces of food per 16 ounces of water. That's a comparison. That's a ratio. So over here, I'm thinking this is going to be food. This is going to be water. Okay, it's important to know which one you put on the top and bottom so that when we go to solve, we set it up correctly. So I already used my 3 tablespoons and my 16 ounces of water. Now they're giving me an 80. I have to pay attention to what it is. It's ounces of water. Okay, so in my proportion, the ounces of water I put on the bottom, so then the 80 has to go on the bottom. And then the question is saying, how many tablespoons of food are needed? So that makes sense because the thing I don't know is up here where I put the food. So now I have a proportion to solve and I can solve it using cross products. So I can take 3 times 80, set it equal to 16 times x. 3 times 80 will give me 240. And then when I do 240 divided by 60, divided by 16, I get x equals 15. But then think about what you're looking for. Tablespoons of plant food. It says how many tablespoons of plant food are needed. So I want to make sure that for my final answer, I put in that I need 15 tablespoons of plant food. So I'm trying to keep it in that same ratio. Like if you're mixing lemonade, you don't want to put in too much lemonade and not enough water, or it'll be really super sour. You don't want to put in too little because it tastes nasty. So if the recipe says use 1 scoop for 10 ounces, but you want to make more, you have to figure out how many scoops should you use to keep that ratio the same. And that's what we're doing here. So this is going to be just some straightforward solving. So the smart thing to do at this point is to stop the video and try it yourself and then see if you're getting it right. But these get a little tricky. I can see number 2 is going to be a little bit tricky. So come on back in and see how I'm setting it up. Okay, I'm going to take this ratio and, proportion, and I'm going to do cross multiplying or cross products. And I like to put the number before the letter. So I'm just going to write it like that. I'm going to go to my calculator, 5 times 45. And then to get that n separated out, I'm going to divide both sides by 25, and n will equal 5. Oh, n will equal 9. Can't do math, apparently. Okay, so this one looks kind of tricky. So this one's going to take me a little bit more thinking. This is a thing. They travel around together. So when I do my cross products, I have to make sure that I'm going to multiply the 6 by the whole thing, not just by the b. The entire bottom, b minus 2, has to get multiplied by 6. So you can probably guess that I'm going to have to do some distributing. And then on the other diagonal, I have 3 times b. So now it looks like something I solved in the earlier part of chapter 3 where I do my checklist. I have to distribute, and then I don't have to do any combining, but I do have to move a b to the other side. I'm going to move the 6 so that I don't end up without any on this side, and it would look so weird. So that's gone. Be careful here. 3 minus 6 is going to put me at negative 3b. So just for clarity, I'm going to move up here. At this point, I have negative 12 equals negative 3b. Dividing out the negative 3, b is 4. Now, that is a problem I don't want to have to do twice in my life. And so I'm going to maybe go back and say, hey, I'm going to check my solution, just like it says. I have 6 over, and then I'm putting in the 4 that I got, equals 3 over 4 minus 2. Okay, well, 6 over 4 equals 3 over 4 minus 2, which is 2. Checking my cross products, that would be 6 times 2 has to equal 4 times 3. And you can see that those are both going to be 12. So that answer works. So then I put it into my IXL or to my assignment check, and I know it's right the first time. Awesome. Alrighty, so let's try this application problem. It says in example 2, so we're going to have to scoot back up here, and we're using this same thing. We're doing the same plant food business. It says, suppose it takes 120 ounces to feed all of the plants. How many tablespoons of plant food are needed? Okay, so if you're looking up here, if you mixed 3 tablespoons of plant food with 16 ounces of water, that's going to be 19 total. Because what's different about this one down here is that it's talking about you need 120 ounces total. And then it's asking how many tablespoons of plant food. So what I want to look for is up here, I want to say how much plant food was involved. 3 tablespoons. Okay, so now I have what I need. It takes me, for food, it takes me 3 tablespoons for a total of 19, because those other 16 ounces were water. Okay, so then I'm going to set that equal to, and the 120 they're giving me, it says 120 ounces to feed all of the plants. So that's actually a total, and therefore it has to go on the bottom where I'm keeping my totals. That means the thing I don't know, the how many tablespoons of plant food are needed, has to go on the top, which makes sense because that's going to tell me how much food is needed. So the tricky part is just getting that set up. Now I can do my cross product, my cross multiplying. 3 times 120 has to equal 19 times x. Now keep in mind that it's okay to not get a perfectly whole number. So you can get decimals in your answers because that's just what happens in real life, is sometimes it doesn't go in perfectly. That's going to probably happen here because when I divide this by 19, I don't get a whole number. I am getting 18.9. And then that's going to be tablespoons of food. Okay. So I'm just setting everything up the same. An architect creates, let's see if we should do this one more. If you totally get it and you want to try your homework, you can go and do that. I'm going to read one more and set it up. An architect creates a scale model of the school. The school is 50 feet high. The ratio of actual school, the ratio of the model to actual school is 1 foot to 75. That's what I need. So if I have 1 to 75, where this is the model and this is actual or real life, here when it says the school is 50 feet high, that's in real life. So then that 50 goes on the bottom, and then it says estimate the height of the model. Well, that's going to be my unknown, is what is the model size if your building that you're trying to model is 50 feet, even though I wrote it in a way that looks like 60. And now I can go ahead and do my cross product. So this stuff, if you're wondering what all this is, it's just the formatting of what I'm already doing. So then I'm going to model them or multiply them, cross multiply. So, excuse me, excuse me. I'd have 1 times 50, and then here I'd have 75 times, I used x, they used h for height. Either way, this is going to be 50 equals 75h. So I have to divide that 75 out of there. And so when I do, if I take 50 and divide it by 75, it's going to turn out to be 2/3 of a foot, or you could have 0.6 repeating. So the height of the scale model is 2/3 of a foot or 0.6 repeating. And then they change that into inches, but that can be kind of tricky. You'd have to do it this way. Well, it doesn't matter. We just won't do that. So we're good. Okay, so your goal today is to kind of know, how do I solve proportions? Help. But when we did it yesterday, we did it kind of the math solving way. Today we're using sort of a little shortcut where if I have something over something equals this over that, I can use my cross multiplying or cross products, where A times D equals B times C. And then once I have that, I can solve for any missing numbers. So if I have an X tossed in there. So use these examples and the filled in notes if you need to